Two properties. I briefly talked about one of these yesterday, so I'll just go back to it. Two properties. They are properties that if you understand logs well enough as far as evaluating, which I hope you do after last night, that they kind of make sense. The first one is, if you have a log and this base is the same as this number, then whatever this exponent is what it simplifies to, what it would evaluate to, okay? In other words, when these two things are the same, no matter what they are, they just go away and that's what's left, okay? And it makes sense if you think about it, because if you think about if you didn't have what it equals here, if you were evaluating this, the thought process would be, okay, b to the what power gives you b to the x. Well, we learned with properties of exponents, if the bases are the same, then the exponents must be the same. So this must equal x. Does that make sense to you? So if I had, for example, what would that equal? Do you understand that if it did not look like that initially, but rather it looked like, yes, somebody said it. That is the same thing, right? Do you recognize that 125 is a power of 5? Yes, and so I could rewrite it as log base 5 of 5 to the third, but the x is still there, right? Everything goes since that's the same and still leaves me with 3x. I went a little bit fast through that one because we talked about it yesterday a little bit. Everybody good on that?
What?
Y'all sure?
Yeah.
So, because I recognized 125 and 5, 125 is a power of 5, I just rewrote 125. 125 is the same thing as 5 to the third. I just rewrote it as 5 to the third, and then because the 5s are the same, all this goes away, and it just leaves you with 3x. All right, the other one looks a little bleh. It is a little bleh. But what it says is if I have, this is property number 2, if I have some base, and then I raise that base to a log that has the same base, then all of this cancels and leaves me with x. It's pretty much the same thing. It is. It's just going the exponential side of it instead of the logarithmic side of it, really. Yes. For example, I don't see a base on this one. It's an implied, that's right, it's an implied 10. Yes, so since these are the same, since this 10 and this 10 are the same, it just equals 4. That makes sense? That's not really the meat of the lesson today, but I'm sure y'all do. How about this one? And then I'll go on. What is ln? What does it simplify to? Why? ln is the same thing as log base e. So it does have the same base. Y'all okay on those two properties? All right, let's do inverses.
Hold on, wait, what just happened?
Because, yeah, this is the same thing as log base e of x. Yes. Happy Pi Day, YouTube. Back, guys. Let's rewind back to when we had something like this, a basic linear function, and I asked you to find the inverse of it. What did you do? You switched x and y, and then you did what? So you solved for y, right? Okay, just a quick little recap there of what that is. Well, now we're going to do this, but we're going to do them with exponentials and logarithms. Yes. I love your enthusiasm, Wills. I love it. Me too. Okay. It does, but you'll see.
Is that your handwriting?
All right, so here's what we're going to have. We're going to have something that looks, we'll start with inverse of exponential. Y'all say I don't label, I don't title your notes as we go, so I'll try today or tomorrow.
No, tomorrow. You can pay right for
All right. So we're going to start out doing the same thing that we did before, and that is switch x and y, right? So now x equals, come on, x equals 6 to the y plus 1. I don't know how to solve that for y, do you? I mean, I told a story. I do know, but you don't. I'm fixing to show you. All right, so what we have to do is we have to isolate. What does isolate mean?
Get it by itself.
Get it by itself. We have to isolate the exponential piece. Exponential piece or term. How would I isolate the exponential part? Subtract 1 from both sides, right? So I would have x minus 1 equals 6 to the y. So I talked a little bit yesterday about why logarithms are useful. And I put something up that was a little bit similar to this. It had a variable in the exponent, right? And I said, you really don't know how to solve for that. But what you can do, let's do a contrasting color. You can change forms. What do I mean by change form? Right now it's in exponential form. I get a log form. How would this become a log? Log base what? What's the base? 6. Log base 6 of x minus 1. It's okay that it's in parentheses like that. That's all made together for the a equals y because logs equal. It's solved for y.
And we're not going to have to graph it.
Yes.
Oh my God. We are? Impossible.
I'm going to put solve because you could have to divide y by something or do something to y. So notice here, we've talked a lot about inverses. Remember, we talked about whenever we were graphing parabolas. What does the inverse of a parabola look like graph? It's on its side, and it's only that half of it because it's a square root. It can't be negative. So the inverse of an exponential would be... Y'all, no, not graphically, but algebraically, yes. Look, if I start with an exponential and I find the inverse, I end up with a log function. Yes? Yes. Well, let's do one more. Finding the inverse. You think this is hard?
It's hard thinking about graphs.
Yeah, I know. We're going to, can you like plug this into I stopped the box.
You could, but I'm going to make you show your work. All right, let's find the inverse. This looks a lot like an exponential that we graphed before. Remember when we were doing the growth and decay? Yes. It is a growth model. Why is it growth? What makes it growth or decay?
The front, the B.
The B. This is the B.
Where's the B?
It's bigger than 1, so that makes it... I like that y'all are remembering this because this will be on your chapter 4 test. All right. As I find the inverse, so this one I'm finding inverse for, I switch x and y. Yes? Yes. Say yes because that's the right answer. Okay, 2 times 5 to the y minus 1 plus 2. My first step is to do what after I should say second step. Isolate. What do I do to isolate? Subtract 2. Good job. And divide by 2, since the 2 is hooked to that exponential piece as well. So, well, you could do 1/2 x, but then you have to do -1. Yeah, you can. I tried to come up with as hard as I could think it would get for you on these.
What? You always say that, and then like on the
The homework doesn't even involve this many steps on. I flipped over and looked.
Oh, really? You did?
Oh my goodness. You know, you are being so exaggerant right now. What do you do now? What's the base? What goes here? Is it solved? Close. You need to add the 1 to both sides. So actually the inverse of this is log base 5 of x minus 2 over 2 plus 1 equals y. So it looks a lot worse. Really, it's just a matter of writing this way. You're not doing anything with it.
Because you did it.
Yeah, I had to get y by itself.
And that's it, really what it is.
That's how to find inverse of exponential pieces. Now we also,
We're gonna have to do like log of log now. That'd be 1, right?
we're also going to go backwards. We found the inverse of the exponential function, which is the logarithmic function, and now we're going to find the inverse of the logarithmic function, which is, guess what? Exponential. You're exactly right. All right, so I'm going to start with something that looks like my first step is going to be the same. It is going to be, in fact, all the steps are the same. The only difference is I can't isolate an exponential piece. I can isolate a logarithmic piece, right? All right, switch x and y. Well, of course, you weren't this advanced in 8th grade. All right, so I get x equals natural log of y plus 3. What was the next step? What did we do next? Isolate. Shh, guys. Isolate the log term. It's already isolated, okay? Because that plus 3 sits in the parentheses, it's hooked to the log and it cannot let go of the log right now, okay? So don't try. We're talking about outside the parentheses or in front of it. What do you do now?
Divide by ln. Change that form.
Can't divide by ln, that's a function. You changed the form, you're exactly right. Once it's isolated, these steps are exactly the same. Now here's the question. I've got natural log of y plus 3 equals x. How do I change the form of that? I don't see a base. The base is e. Good job, y'all. I tried to throw you off and it did not work. So it's e to the what?
For x?
I thought ln was e.
It is.
So why?
I don't even know where the frick. Oh, because whatever.
So why are we trying to
It's
Now you gotta
natural
subtract.
log, which is log.
Logs equal exponents. This is the exponent. Yes, we're going to subtract 3. You're jumping ahead, but yes. It does. So this is log base e. We changed the form to exponential. So e to the x equals y plus 3.
You see, saying do you write log?
You don't.
No. This is where we're going from this form to this form.
So log goes away.
So the log goes away, yes.
Just.
Well, it's just writing it a different way. It's like writing the square root of x and x to the 1/2. The radical's gone, but it still means the same thing. No, it won't. Somebody said we need to subtract 3, and we do.
So our test isn't even just on this, it's on everything else too. Oh my gosh.
Really?
So now, think with me for just a second. We know that the inverse of logs is what? Exponential. So we're talking growth decay. So when we talk about growth decay, remember we had an asymptote and maybe something like that. That's a decay, right? If you think about the way inverses work, they switch x and y, right? Kind of like a rotation. So if this is exponential, then logs look like this.
So it's like if you're going like X is
Yeah. Instead, the asymptote is vertical, so it's x equals, so it could be the y-axis instead of the x-axis. Here, my domain is restricted rather than my range. Okay? Because then that makes sense, because x and y is swapped, right? So if you look at it as the inverse of an exponential, it makes it infinitely easier.
The one on the right's a log. Did you say it was?
Yes, this is a log. Okay? All right, let me show you how to graph. Here's what they look like.
I was doing some stuff.
The hardest part about this is picking the values that you will be able to find whole numbers for. We still only need 2 points. Okay? You just have to kind of reason through this, and you have to be good at evaluating logs to pick those points. Okay? All right. I think the best way with this is just an example. Remember in exponential, this was my asymptote, right? Everything's flipped now, though, right?
so it's gonna be
This is my asymptote. And this time, it's vertical, not horizontal.
The 3.
Yep. So I'm going to change the sign again because it's in parentheses. Opposite sign. So here, well, not just because it's in parentheses, but actually, it's always going to be the opposite sign. The actual formula is like log base b of x minus h plus k. And because the original is a minus sign, it changes the sign. But it's still, what I'm getting at is your h is still opposite sign. Your h has always been opposite sign. Your h is always going to be opposite sign. All right.
Wait.
Okay. Tell me when you're ready. I'm not changing the slide. I'm just going to draw the vertical asymptote. Is that okay? Okay. 1, 2, and 3.
Hang on.
I didn't do anything. I just drew the asymptote. All right. I need 2 easy points. Okay? Just like with the growth and decay, I had easy points. Only one of them I pulled from the equation. I'm not going to be able to do that here. I want you to think about this, okay? Think about this as you plug in. I need to think of something I could plug in for x that's going to make that log easily evaluatable, if that makes sense. In other words, if I have log base 2, what could I put in this spot and just know the answer for very easily? 4. If I made this become 4, I would know that it equals what? 2. So how could I force this to be 4? Let x equal what? 1. Okay. If x equals 1, and this is going to vary per problem, y'all. You're going to have to look at it to see. Then y equals log base 2 of 4 plus 1. We said that's 2, and 2 plus 1 is 3. So 1 point on this graph is 1, 3. Okay.
Either 2 or where the second
2.
plus 1.
In the original equation.
Like y equals log base 2 plus 1.
This original equation.
Okay, then
What second one?
Log 2.
The log base 2 of 4 is 2.
So you solved that before?
You do log first, yes. You have to evaluate the log first and then add whatever else is there. This is the one where I asked and Corbin said, oh, if 4 was right there for the A. What could you make this equal that would make the log portion easy to evaluate? Yes. Look at it one more time because I need 2 points, guys. This is not easy. I need y'all with me, okay? What else? If I have log base 2, what is something that if I put here is a small, nice, easy number 2? I would go with 2 also, Ellen. I think if this was 2, that would make it easy because anytime these are the same, it just equals 1, right? Okay. So how could I make this 2? What would I need to put in for x? -1. So if x equals -1, then y equals log base 2. I'll plug it in like this time so you can see. Right? So log base 2 of 2. And we said log base 2 of 2 is what? And 1 plus 1 is? This is the hardest part about graphing the logs. And that's why another reason we spent so long on the evaluating part is because the more comfortable you are evaluating and seeing how logs simplify, the easier this is. All right, so this point is -1, 2. You should be able to see now how it curves because it curves towards the asymptote. It is a growth or decay on its side is all it is. It takes longer because you have to reason through it. That's why. How about the domain? It's -3 to infinity because domain is left to right. This time instead of the range restricted, it's the domain restricted. How about the range? Range will be negative infinity to infinity. Absolutely.
Wait, so the hardest part is this time to figure out.
Which points are the easiest to, yeah. And really the easiest things to do, if you can't think, is to make this be whatever the base is, or to make this be 1. Because if you make this be 1, it's always going to equal 0. The easiest thing to do is to make, if you ever have the same base, it's always going to equal 1. Right? Because the bases, so if you can force the bases to be the same. The other thing is, what did I say? Oh, if you can make this be 1, this is always going to equal 0 because the only way to get 1 when you raise it to a power is 0. So those are the two easiest points to choose. Force the same base or force this to be 1.
So, this is one of the hardest things.
Don't have the numbers in parentheses. Obviously, if it doesn't have those in parentheses, it's a little easier to work if it'll come back. Like a lot of them are just log base 2 of x. Wills! What the heck are you doing? We're not dance battling in math class. This is from your homework. This is number 53.
Yeah.
Make it harder as you go. This is the last one.
Is this a live question?
Well, you did half the lesson yesterday.
Wait, what?
You did half the lesson yesterday. All right. So I'm graphing, right? Where is my asymptote? Oh, y'all got that down.
It's not hard. Well, that's not.
Is it soft though?
Wheels.
Me, bro.
I know, that's why I said wheels.
He says that was me. Wait,
All right.
I didn't do anything.
All right. I need some easy X's. I don't know why I put this so far over.
Oh, that was so satisfying. Oh my.
All right. I need some good X's, and this is where I was telling you. If you can make this the same as this, that's one easy point, okay? And then if you can make this be just 1, that's another easy point, okay? All right, so what could I let X be to force the base to be the same? 4. Because when X is 4, that means I have log base 5 of 4 plus 1 minus 3, which is log base 5 of 5. And we know that any time the base is the same like that, it just simplifies down to 1 minus 3. Negative 2. You go ahead and put it in. 1, 2, 3, 4. Negative 2. Is it supposed to be like what?
Do we have any way of knowing if this is the growth of the K model? Or we just figure it out?
I mean, you can change the form if you wanted to. Yeah. Yeah.
What is that for?
That point is 4, negative 2.
So what do I do for this?
What do you do for the next one, Wills? You tell me.
X equals 0.
If you can force that to be a 1 right there.
0.
So log base 5 of 0 plus 1 minus 3. Negative 1 will be undefined. I'm sorry. I can't hear where it comes from.
So it'd be 0
It was. I got the vicinity close. That's a 1. Yes.
Well, like that ends
Yes.
up being 0.
Because 5 to the what power is 1? Anytime that number is 1, it equals 0.
Wait, hang on, man.
Anytime your A is 1.
Alright, well.
It's a nice little property that you can remember. Yeah. Yeah.
Oh, it's always 0.
What's the domain?
Negative 1 to infinity.
What's the range?
Infinity.
Tell me what you think about graphing logs.
It's not that bad.
All right, so we did 3.